Picture the Sahara at twilight, when the day as furnace heat begins its slow retreat and the first breath of evening wind stirs the sand. The dunes stretch endlessly, their crests sharp as knife edges against a sky painted in copper and gold. Here, in this vast cathedral of silence, time moves differently. A grain of sand that falls today might not settle for 1,000 years, carried on winds that have blown since before human memory began. But beneath your feet, beneath the shifting, breathing surface of this sandy ocean, something waits. Something that has been waiting for millennia, patient as stone, persistent as water. The desert keeps its secrets well, yet sometimes when the wind is just right and the light falls at the perfect angle, you can almost hear them. Whispers of vanished cities, echoes of voices that once called these wastes home. The Sahara was not always this silent tomb of sand. Once, rivers ran here. Once, forests grew green beneath African skies. Once, people built and dreamed and loved in places now buried so deep that their very existence has become myth. The desert remembers, even when we forget. It holds its treasures close, wrapped in layers of time and sand, waiting for the right moment to reveal what we thought was lost forever. Tonight, as the stars emerge in their ancient patterns above the dunes, we begin a journey into that hidden world. We'll walk the paths of civilizations that flourished when the Sahara was green, explore the evidence scattered like breadcrumbs across thousands of years, and ask the questions that archaeologists whisper in the dark. What if everything we think we know about humanity's first cities is wrong? What if the greatest urban centers of the ancient world lie not along the fertile banks of rivers we can see, but buried beneath an ocean of sand? The desert wind carries more than dust. It carries stories. And some of those stories, if we listen carefully enough, might just rewrite history itself. 9,000 years ago, a traveler standing where today only sand stretches to the horizon would have seen something impossible. Water, not the desperate trickle of a seasonal wadi, but broad rivers flowing strong and steady toward inland seas that sparkled like jewels beneath the African sun. The Sahara, that name we associate with endless, lifeless dunes, was once a paradise that would have made Eden seem austere. The African humid period, as climatologists now call it, lasted for nearly 4,000 years. Monsoon rains swept inland from both the Atlantic and Indian Oceans, feeding a vast network of lakes and rivers that transformed North Africa into a green continent. Hippos wallowed in Saharan streams. Crocodiles basked on riverbanks where today only camel bones bleach in the sun. Elephants, giraffes, and antelope roamed grasslands that stretched from the Atlantic to the Red Sea. But this wasn't just a zoological paradise. Where water flows, people follow. Archaeological evidence scattered across the now barren landscape tells of fishing. Communities that thrived along those ancient shores of pastoral peoples who followed the rains with their herds of settled. Farmers who grew grain in what are now the most desolate corners of the earth. Rock art galleries hidden in remote cliff faces show us their world. Boats navigating rivers that have unflowed for millennia. Cattle grazing in meadows now buried beneath mountains of sand. The transformation that followed was neither gradual nor kind. Around 5,500 years ago, the rains began to fail. The monsoons shifted south, following changes in Earth's orbit and tilt that occur over cycles spanning tens of thousands of years. Rivers that had flowed for millennia began to shrink, then disappear entirely. Lakes that had been the centers of thriving civilizations became salt flats, then empty basins, then burial grounds for the communities that had once flourished on their shores. What happened to those people? Some, undoubtedly, followed the retreating waters south and east, joining the growing populations along the Nile and other permanent rivers. But others, perhaps, chose to stay. They dug deeper wells, built more efficient water storage systems, created oasis settlements that could survive on the memory of plenty. For centuries, possibly millennia, they persisted in a landscape growing ever more hostile, their cities gradually swallowed by the advancing sand. The green Sahara died, but it didn't die overnight. It took thousands of years for the desert to claim its current dominion, and in those centuries of slow transformation, entire civilizations may have risen and fallen in places now so desolate that we can barely imagine them ever supporting life at all. In the shadowed halls of medieval libraries, among manuscripts yellowed with age and maps drawn on vellum by long-dead hands, curious references appear again and again. Arab geographers spoke of cities in the deep desert, oasis settlements days or weeks beyond the known caravan routes. Medieval European maps, copied from still more ancient sources, show rivers and settlements in regions that had been lifeless desert for centuries by the time the mapmakers set pen to parchment. Herodotus, a tireless collector of stories both true and fabulous, wrote of expeditions that ventured deep into the Sahara and returned with tales of distant peoples and hidden waters. A Roman historian Tacitus recorded similar accounts, describing military expeditions that crossed vast desert distances to reach populations that common sense insisted could not exist. Were these merely travelers' tales, the ancient equivalent of sea monsters drawn at the edges of medieval maps? Or were they recording real places, settlements that had already begun their slow burial beneath advancing dunes? The mystery deepens when we examine the Piri-Reis map, that famous 16th century chart that has puzzled historians for decades. Created by the Ottoman admiral Piri-Reis in 1513, the map purports to show the Americas with startling accuracy for its time. But it also shows details of Africa that shouldn't have been known to medieval cartographers. Inland rivers, mountain ranges, and what appear to be cities located deep in regions that were already desert by Piri-Reis' time. The admiral claimed his map was compiled from more than 20 ancient sources, some dating back to the time of Alexander the Great. If true, those source maps might have recorded the Sahara as it existed during its green period, complete with the rivers, lakes, and settlements that thrived there before the Great Desiccation began. When later copyists reproduced these maps, they may have unknowingly preserved evidence of a lost world. But the most intriguing references come from Arab texts of the medieval period. The great geographer al-Idrisi, working at the court of the Norman king Roger II of Sicily in the 12th century, compiled accounts from merchants and travelers that spoke of thriving cities in the deep desert. His descriptions are tantalizingly specific: walled settlements surrounding springs that never failed markets, where gold and salt changed hands in quantities that suggested extensive trade networks, astronomical observatories, where desert scholars tracked the movements of stars across skies unobscured by the humidity of more temperate climates. The Arab historian Al-Umari wrote of diplomatic contacts with rulers whose domains lay far to the south and west of any known settlements, in regions his contemporaries regarded as uninhabitable wasteland. Were these merely confused accounts of more accessible kingdoms, distorted by the notorious unreliability of long-distance communication? Or were they the last recorded contacts with civilizations already beginning their final retreat before the advancing sand? Perhaps most compelling of all are the maps drawn by the Tuareg, the blue men of the desert, who have navigated the Sahara's trackless wastes for over 1,000 years. Their traditional route maps, passed down through generations of desert guides, show watering places and landmarks that correspond to no features visible on the modern landscape. When asked about these discrepancies, elderly Tuareg sometimes speak of places their grandfathers described sites that were already ruins when their people first ventured into the deep desert. Stones arranged in patterns that suggested they had once been something more than random geological formations. From space, the Sahara reveals secrets invisible to those who walk its surface. Satellite images captured in various wavelengths of light show ghostly patterns beneath the sand, perfectly straight lines that stretch for kilometers, geometric shapes too regular to be natural, rectangular formations that suggest city blocks laid out by human hands thousands of years ago. Ground-penetrating radar has transformed archaeology in recent decades, allowing researchers to see through soil and sand to map buried structures without disturbing the surface. When these instruments are turned toward the Sahara's mysterious subsurface anomalies, they reveal formations that challenge our understanding of the ancient world. In Libya's Fezzan Basin, radar surveys have detected vast rectangular complexes buried beneath dozens of meters of sand. The patterns suggest extensive urban planning, wide boulevards intersecting at right angles, what appear to be large central squares surrounded by smaller structures, even what might be the remains of defensive walls. Thermal imaging from orbiting satellites adds another layer to the mystery. Sand-covered stone retains and releases heat differently than sand alone, creating subtle temperature variations that sophisticated sensors can detect. These thermal signatures have revealed the outlines of structures scattered across thousands of square kilometers of supposedly empty desert. Some formations are enormous, larger than many modern cities, while others appear to be smaller, settlements connected by what look like ancient roadways. The most intriguing discoveries come from LiDAR surveys, which use laser pulses to create incredibly detailed three-dimensional maps of surface features. When applied to partially buried sites at the desert's edges, LiDAR has revealed the full extent of ruins that archaeologists had thought were merely scattered stone foundations. What appeared from ground level to be random debris proves, when seen from above, to be the remains of extensive architectural complexes, buildings arranged around courtyards, long halls that might have been temples or administrative centers, even what appear to be aqueduct systems designed to channel and conserve precious water. But the most compelling evidence may be the hardest to quantify: the simple fact that these patterns exist at all. Geological processes, even over thousands of years, don't create the kind of regular geometric forms that satellites are detecting beneath the sand. Wind and water erosion produce curves and irregular shapes, not the straight lines and right angles that suggest human construction. Mineral deposits and sedimentary layers form organic patterns that follow the natural contours of ancient landscapes, not the rigid geometries that urban planners impose on the world. Yet mainstream archaeology remains skeptical. The academic consensus holds that pre-dynastic North African cultures were primarily nomadic, lacking both the population density and organizational structures necessary for large-scale urban construction. The patterns visible from space, according to this view, are more likely to be unusual geological formations, perhaps ancient lava flows or mineral deposits that happen to create regular shapes through purely natural processes. This skepticism may be warranted, but it faces a growing challenge from the evidence itself. Each new survey reveals more patterns, more structures, more suggestions that the blank spaces on our maps of ancient Africa may not have been blank at all. The technology exists to resolve these questions definitively, but doing so would require extensive excavation, projects in some of the most remote and politically unstable regions on Earth. Meanwhile, the patterns wait beneath the sand, regular as city grids, patient as the stones they may once have been. Whether they represent the greatest archaeological discovery of the modern era, or simply the most elaborate case of wishful thinking in the now, history of remote sensing remains, for now, a question that only the desert can answer. Beneath the endless dunes of the Sahara lies a ghost, the fossilized memory of one of Earth's greatest river systems. The Tamanrasset River, as geologists have named it, once flowed north across the entire breadth of Africa, carrying water from the highlands of Chad and Sudan to the Mediterranean Sea. Its ancient course can still be traced in satellite images, a pale line threading through the sand, marked by subtle differences in surface texture that reveal where water once carved channels through bedrock that now lies buried beneath hundreds of meters of accumulated dust. This wasn't merely a large river, it was a continental artery, comparable to the modern Nile or Amazon. Geological surveys reveal that during the African humid period, the Tamanrasset's main channel was over 1 kilometer wide in places, with a watershed that drained nearly a quarter of the African continent. Dozens of major tributaries fed into it, creating a network of waterways that would have supported extensive navigation and trade. Ancient beaches and river terraces, now exposed only where erosion has stripped away the overlying sand, show that this system persisted for thousands of years. But the Tamanrasset wasn't alone. Radar surveys have mapped the courses of at least 17 major river systems that once crossed what is now barren desert. The Kafur River flowed eastward from the Tibesti Mountains to join the Nile, somewhere in what is now southern Egypt. The Ahar River drained the central Sahara, northward toward Tunisia and Algeria. Each of these systems was large enough to have supported significant human populations along its banks. The implications are staggering. Rivers of this size don't just support scattered fishing camps or seasonal settlements. They create civilizations. The Nile gave birth to Pharaonic Egypt. The Indus River nurtured one of humanity's earliest urban cultures. The Yellow River became the cradle of Chinese civilization. If the Sahara once hosted 17 river systems comparable to these historical examples, then the human societies they supported might have been equally complex and extensive. Archaeological evidence scattered along these buried waterways supports this possibility. At Gabbero, in what is now Niger's Tenor Desert, teams led by paleontologist Paul Serrano have uncovered a site that was continuously occupied for over 5,000 years during the Green Sahara period. The remains found there tell of fishing communities that lived in permanent settlements, crafted sophisticated pottery, and developed burial practices that suggest complex social structures. Similar sites dot the courses of other ancient rivers, suggesting that the Green Sahara supported not just scattered nomadic groups, but extensive networks of settled communities. The most tantalizing discoveries come from the confluence points where major rivers once joined. At several such locations, ground-penetrating radar has detected what appear to be large architectural complexes structures, too extensive and organized to be natural formations, but too deeply buried to excavate without massive investment in remote desert archaeology. These sites occupy exactly the positions where ancient urban planners would have built major cities, at the junctions of transportation networks, in locations that could control trade between different regions. As the climate changed and the rivers began to fail, these communities faced an impossible choice. They could abandon their cities and follow the retreating waters to more reliable sources, or they could adapt in place, developing technologies to survive in an increasingly arid environment. Evidence suggests that many chose the latter course, at least initially. Wells were dug deeper, water storage systems became more sophisticated, and settlements contracted around the most reliable springs and water sources. For centuries, possibly millennia, these communities may have persisted as the rivers disappeared around them. Their cities, built originally on the banks of broad waterways, found themselves increasingly isolated as the desert advanced. Cut off from traditional trade routes and struggling to support populations that had grown during the centuries of plenty, these settlements may have gradually been abandoned, their buildings slowly swallowed by the advancing sand. Today, the Sahara as hidden rivers exist only as faint lines on satellite, images in buried channels detected by ground-penetrating radar. But they represent something more than geological curiosities. They are the potential locations of humanity's lost urban prehistory, the places where our species may have first learned to build cities and organize complex societies in the green heart of Africa. In 2013, something impossible emerged from the sands of Chad's Borkou region. A Roman merchant vessel, complete with amphorae and bronze fittings, sitting in splendid isolation more than 500 kilometers from the nearest body of water. The discovery made headlines around the world, not just for its improbability, but for what it suggested about the desert's power to preserve and conceal. The ship wasn't small, nearly 20 meters in length. It would have required a crew of at least a dozen men and could have carried several tons of cargo. Carbon dating of the wooden hull confirmed what the artifacts already suggested. This was a genuine Roman-era vessel, built sometime between the 2nd and 4th centuries CE. But how does a seagoing ship end up buried in sand in one of the most landlocked locations on Earth? The official explanation involves a complex geological scenario. During certain periods, flash floods in the central Sahara can create temporary lakes that persist for months or even years. The theory suggests that Roman traders, following well-established trans-Saharan routes, might have used such temporary waterways for transport, only to find themselves stranded when the waters receded faster than expected. Unable to move their heavy vessel overland, they would have been forced to abandon it, leaving the desert to slowly bury their loss. But this explanation, while plausible, raises as many questions as it answers. Roman merchants were notoriously practical. They didn't invest in expensive vessels for speculative ventures into unknown waters. The presence of this ship suggests that navigation of Saharan waterways might have been more common than we imagine, routine enough to justify the construction of purpose-built vessels for inland African trade. The cargo found with the ship provides additional clues. Along with the expected amphorae for oil and wine, archaeologists discovered samples of gold, ivory, and what appeared to be worked gems, exactly the kind of high-value, low-bulk goods that made trans-Saharan trade profitable. The ship wasn't just a stranded vessel. It was part of a sophisticated commercial network that linked the Mediterranean world with the riches of sub-Saharan Africa. Even more intriguingly, the ship's construction showed modifications that suggested regular use in shallow, sand-choked waters. The hull had been reinforced with additional bronze fittings, and the keel showed wear patterns consistent with frequent grounding and refloating. This was on a vessel that had made a single unfortunate journey into the desert. It was built for repeated voyages through the challenging waters of the dying Sahara. The discovery highlights a fundamental truth about desert archaeology. The same conditions that make the Sahara seem lifeless also make it an incomparable preservative. The extreme dryness that kills vegetation and drives away animals also prevents decay, creating a vast natural museum where artifacts can survive for millennia in conditions that would destroy them anywhere else. The Romang ship, perfectly preserved beneath the sand, may be just one example of thousands of similar time capsules waiting to be discovered. But preservation comes with a price. For every artifact the desert preserves, it buries 100 others beneath shifting dunes. The Romang ship was discovered only because unusual wind patterns had scoured away enough sand to expose part of its hull. Countless other vessels, structures, and settlements may lie just meters beneath the surface. Invisible and inaccessible, their stories locked away until some future shift in the eternal dance of wind and sand brings them briefly to light. The ship in Chad stands now as a monument to the desert's dual nature, destroyer and preserver, eraser of civilizations and keeper of their memory. In its wooden ribs and bronze fittings, we can read the story of a world where the Sahara was not a barrier but a highway, not empty wasteland, but a bridge between continents. It reminds us that our maps of the ancient world may be more incomplete than we ever imagined. Walk through the halls of any major archaeological institution, and you'll encounter a consensus so firmly established, if rarely questioned. The pre-dynastic peoples of North Africa were nomads. According to this view, the communities that thrived during the Green Sahara period were pastoral societies that followed seasonal rains with their herds, living in temporary camps and leaving behind little more than scattered pottery sherds and the occasional stone tool. This interpretation is unarbitrary. It's based on decades of careful archaeological work across the Saharan regions that are accessible to scientific investigation. The evidence consistently shows mobile cultures that adapted to changing environmental conditions by moving rather than building. Their art, painted and carved on rock faces across the Sahara, depicts herders driving cattle, women gathering wild grains, hunters pursuing game across open grasslands. These are the images of people on the move, not settled urban dwellers. Professor David Mattingly of Leicester University, one of the foremost experts on ancient Saharan cultures, argues that the absence of substantial architectural remains is itself evidence for nomadism. If large urban centers had existed in the Green Sahara, he points out, we would expect to find traces of them at sites where erosion has stripped away the overlying sand. The fact that we don't find such evidence, despite decades of searching, suggests that it simply doesn't exist. The archaeological record from more accessible desert margins supports this interpretation. Sites like Nabta Playa in southern Egypt show evidence of seasonal occupation over thousands of years, but the structures found there are modest stone circles that might have been foundations for temporary dwellings, not the massive foundations that would be expected from permanent urban settlements. Even the famous astronomical alignments at Nabta, while impressive, could have been created by mobile groups that returned to the site periodically rather than maintained by a permanent urban population. Mainstream archaeologists also point to practical constraints that would have limited urban development in the ancient Sahara. Before the development of iron tools and sophisticated water management technologies, large-scale construction projects would have been extremely difficult in desert environments. The logistics of quarrying stone, transporting building materials, and supporting large construction crews would have been challenging enough in temperate climates. In the harsh conditions of even the Green Sahara, they might have been impossible. The patterns of settlement visible in other early urban civilizations provide additional context. Cities like Catalyuk in Turkey or Jericho in Palestine developed in locations with permanent water sources and fertile soils that could support dense populations year-round. While the Green Sahara was certainly more hospitable than today's desert, it was still subject to seasonal variations in rainfall and temperature that would have made permanent urban settlement challenging. Furthermore, the transition from nomadism to settled agriculture that preceded urbanization in other parts of the world appears to have been delayed or absent in much of Saharan Africa. While communities in the Nile Valley were developing complex agricultural systems and beginning to build permanent settlements, their contemporaries in the Saharan interior seem to have maintained mobile lifestyles adapted to the region's environmental uncertainties. Dr. Elena Garcia of the University of Casino, who has spent decades studying Saharan archaeology, emphasizes the sophistication of nomadic societies. The absence of permanent architecture doesn't indicate cultural poverty. These were complex societies with rich traditions, sophisticated technologies, and extensive trade networks. They were perfectly adapted to their environment, which is precisely why they remained mobile. Yet even mainstream archaeologists acknowledge that the vastness of the Sahara and the political instability of many regions where ancient sites might be located means that large areas remain essentially unexplored. The absence of evidence, they admit, is not necessarily evidence of absence. The question is whether the patterns detected by satellite imagery and ground-penetrating radar represent natural geological formations or the remains of settlements that mainstream archaeology hasn't yet discovered. This cautious approach reflects the rigorous standards of scientific archaeology, where extraordinary claims require extraordinary evidence. Until excavations can confirm the artificial nature of the subsurface anomalies detected by remote sensing, mainstream scholars will continue to favor explanations based on the well-documented nomadic cultures that we know inhabited the Green Sahara. In the sprawling marketplaces of medieval Cairo, where merchants from across the known world gathered to trade in spices and gold, stories were told of a city that gleamed like pearls in the desert's heart. The Arab chroniclers called it Zerzura, the White City, a place where buildings carved from salt white stone rose from an oasis so green and abundant that those who found it never wanted to leave. But Zerzura was protected, the story said, by jinn and serpents, and by the desert itself, which revealed the city only to those it deemed worthy. The legend appears in dozens of medieval Arabic texts, each version adding new details to the mysterious city's description. According to the most consistent accounts, Zerzura lay somewhere in the western desert, perhaps 7 days' journey beyond the last known oasis. The city was said to be surrounded by walls of white stone, with gates guarded by statues of birds, and these gates would open only for those who knew the proper words to speak. Inside, buildings of marble and alabaster surrounded gardens fed by springs that never failed, where date palms heavy with fruit cast shade over pools of crystal-clear water. The 14th century historian al-Makrizi recorded several accounts of expeditions that claimed to have reached Zerzura. One tale told of a merchant from Damascus who, lost in a sandstorm, stumbled upon the city purely by chance. He described broad avenues paved with polished stone, markets filled with goods from across Africa and beyond, and inhabitants who seemed to live in a state of eternal prosperity. When he tried to return with companions to prove his story, however, the city had vanished, hidden once again behind veils of shifting sand. European explorers of the colonial period became obsessed with finding Zerzura, viewing it as the ultimate prize in the grand game of African exploration. Laszlo Almasi, the Hungarian aristocrat whose exploits inspired The English Patient, spent decades combing the western desert for traces of the lost city. His expeditions, conducted with military precision and the latest navigation equipment, covered thousands of square kilometers of previously unmapped terrain. While he never found Zerzura itself, Almasi discovered numerous archaeological sites that suggested the western desert had once supported much larger populations than anyone had previously imagined. The Italian explorer Prince Kemal el-Dine conducted similar searches in the 1920s and 1930s, following every lead and rumor that might point toward the legendary city. His expeditions were meticulously documented, complete with photographs and geological surveys that provide valuable baseline data for modern researchers. Like Almasi, he found tantalizing hints ruins that seemed too extensive to be simple caravan stops, rock art that depicted urban architecture, local guides who claimed their grandfathers had spoken of cities in the deep desert, but Zerzura itself remained elusive. Modern analysis of these historical accounts suggests that the legend of Zerzura might preserve genuine memories of real settlements. The consistency of certain details across widely separated sources is striking. The white stone construction, the location in the western desert, the association with permanent water sources, and especially the recurring motif of gates that open only to those who know the secret. These elements appear in accounts spanning several centuries and originating from different cultural traditions, suggesting they might be based on actual observations rather than pure imagination. Archaeological surveys using satellite imagery have identified several locations in the western desert that match aspects of the Zerzura descriptions. The Gilf Khyber Plateau, in particular, contains numerous sites where unusual geological formations create natural gateways through white limestone cliffs, and where hidden valleys preserve vegetation that would have been much more extensive during the Green Sahara period. Ground surveys of these areas have revealed scattered pottery, worked stone, and other artifacts that indicate human occupation, though nothing approaching the scale suggested by the Zerzura legends. Perhaps the most intriguing interpretation of the Zerzura myth comes from ethnographers who have studied the oral traditions of Saharan peoples. They suggest that Zerzura might not refer to a single city at all, but rather to a type of settlement oasis communities that developed sophisticated urban characteristics during the Green Sahara period, but which were subsequently abandoned and buried as the climate changed. In this interpretation, the various expeditions that claim to have found Zerzura might each have discovered different sites, all sharing certain characteristics that had been preserved in collective memory as the attributes of a single legendary city. The search for Zerzura continues today, though with tools that medieval chroniclers could never have imagined. Satellite archaeology and ground-penetrating radar offer the possibility of locating subsurface structures that might correspond to the legendary White City. Whether these modern techniques will finally solve the mystery of Zerzura remains to be seen. But the persistence of the legend itself suggests that somewhere in the vastness of the Western Desert, memories of a lost urban civilization continue to whisper across the sand. As the last ice age released its grip on Earth some 15,000 years ago, the Sahara began its transformation from barren wasteland to verdant paradise. The shift happened gradually at first, then with gathering momentum as changing orbital patterns redirected the monsoons northward, bringing life-giving rains to a landscape that had been starved of moisture for millennia. Within a few thousand years, the greatest desert on Earth had become a vast savanna dotted with lakes and threaded with rivers, supporting communities of humans, animals, and plants in numbers that would be unimaginable today. The people who moved into this green Sahara weren't primitive nomads scratching out a bare subsistence. Archaeological evidence scattered across North Africa tells of sophisticated cultures that developed complex technologies, extensive trade networks, and artistic traditions of remarkable beauty and sophistication. At sites like Tassili Nasr in Algeria and the Akakis Mountains in Libya, rock art galleries preserve thousands of images that document their world. Scenes of cattle herding, boat navigation, ceremonial gatherings, and daily life in communities that appear to have been both prosperous and stable. But perhaps the most intriguing evidence comes from the astronomical sites that these cultures left behind. At Nabta Playa in southern Egypt, stone circles and standing stones create complex alignments that track the movements of stars and seasonal changes with remarkable precision. The site predates Stonehenge by at least 1,000 years and shows a level of astronomical knowledge that suggests organized, long-term observations conducted by communities with both the time and expertise to study the heavens. The builders of Nabta Playa weren't content with simple seasonal markers. Their stone arrangements track the precession of the equinoxes, the slow wobble in Earth's axis that takes nearly 26,000 years to complete a full cycle. Creating such alignments requires not just sophisticated astronomical knowledge, but also the institutional continuity to maintain observations across many generations. This suggests communities with stable leadership, specialized knowledge keepers, and enough surplus production to support full-time astronomer priests. Similar astronomical sites have been found scattered across the Green Sahara's former territory. In the Air Mountains of Niger, stone arrangements appear to mark the positions of bright stars at specific dates thousands of years ago. In Chad's Enedi Plateau, carved petroglyphs show star patterns that correspond to ancient constellation maps. Each site represents not just astronomical knowledge, but the kind of organized, persistent effort that requires settled communities with complex social structures. The implications go far beyond astronomy. Cultures that can organize massive stone construction projects, maintain precise astronomical observations across generations, and create artistic traditions sophisticated enough to influence neighboring civilizations are not simple nomadic groups. They are organized societies with specialized labor, permanent leadership structures, and the agricultural surplus necessary to support non-food producing specialists like astronomers, artists, and architects. Where did these people go when the rains failed and the Sahara began its transformation back into desert? The conventional answer is that they migrated to the Nile Valley, joining the populations that would eventually become pharaonic Egypt. This migration model is supported by cultural and technological similarities between late Green Sahara sites and early Egyptian developments. The astronomical knowledge evident at Nabta Playa, for instance, shows up later in Egyptian temple alignments and calendar systems. The artistic styles of Saharan rock art influence early Egyptian tomb paintings and decorative motifs. But migration doesn't necessarily mean abandonment. Archaeological evidence suggests that many Saharan communities attempted to adapt in place as their environment changed, developing increasingly sophisticated water management technologies and concentrating around the most reliable oases. These adaptation efforts might have been successful for centuries, or even millennia, creating urban settlements that persisted long after the surrounding landscape had become desert. The builders who created Nabta Playa and the other astronomical sites of the Green Sahara possessed skills that would have served them well in such adaptation efforts. Their ability to organize large construction projects, their knowledge of stoneworking techniques, and their understanding of water management, evident in the elaborate drainage systems found at several sites, would have been invaluable in creating sustainable settlements in an increasingly arid environment. Recent discoveries in southern Egypt and northern Sudan have revealed evidence of communities that successfully made this transition, creating oasis civilizations that flourished for thousands of years after the Green Sahara ended. These settlements show clear technological and cultural continuities with the earlier Green Sahara cultures, suggesting that the builders' trail didn't end at the Nile. It continued into the heart of the desert, where their descendants may have created the urban centers that legends like Zerzura remember. 4 hours by four-wheel drive south of Aswan, where the Nile cuts its ancient course through granite and sandstone, lies a place that challenges everything we think we know about humanity's first steps toward civilization. Nabta Playa appears unremarkable at first glance, just another patch of desert where scattered rocks break the monotony of sand and gravel. But these aren't random stones arranged by wind and weather. They are the remains of humanity's oldest known astronomical observatory, built by people who watched the stars with scientific precision more than 7,000 years ago. The site was discovered in 1973 by archaeologist Fred Wendorf, who was conducting a survey of prehistoric sites in southern Egypt. What caught his attention wasn't the stone circles themselves, but the pottery sherds and other artifacts scattered around them, evidence of human occupation dating back to when this barren landscape was the shore of a seasonal lake. Only when Wendorf and his team began mapping the stone arrangements did the true significance of Nabta Playa become apparent. The builders had created multiple stone circles, each precisely oriented to capture specific astronomical events. The central circle, about 4 meters in diameter, contains 4 pairs of standing stones arranged to frame the summer solstice sunrise. Other stones mark the cardinal directions with an accuracy that would not be out of place in a modern astronomical facility. Most remarkably, a complex arrangement of larger stone slabs appears to create a 3-dimensional star map, representing the constellation Orion as it appeared in the sky thousands of years ago. Dr. J. McKim Melville of the University of Colorado, who led the archaeological astronomy team that decoded Nabta's alignments, describes the site as Africa's Stonehenge, but older and in some ways more sophisticated. The builders didn't just track the annual cycle of seasons. They monitored the slow precession of the equinoxes, the 26,000-year wobble in Earth's axis that gradually shifts the positions of stars relative to the horizon. Creating alignments accurate enough to track this subtle change requires not just advanced knowledge, but generations of patient observation and record-keeping. But Nabta Playa's sophistication goes beyond astronomy. Excavations have revealed that the site was in use for over 1,500 years, during which it underwent multiple phases of construction and modification. The earliest stone circles were relatively simple, but later builders added increasingly complex alignments, suggesting a tradition of astronomical knowledge that grew more sophisticated over time. This wasn't a single brilliant insight, but a sustained scientific enterprise that lasted for dozens of generations. The human cost of building Nabta Playa would have been enormous. The largest stone slabs weigh over a ton each and had to be transported from quarries kilometers away. The precision of the alignments required not just brute labor, but skilled craftsmen who could cut and position stones with millimeter accuracy. Supporting such an enterprise would have required a surplus economy capable of feeding workers who contributed nothing to immediate survival needs. Even more intriguingly, chemical analysis of the stones reveals that many came from geological formations hundreds of kilometers away. This suggests not just organized construction, but extensive trade networks that could transport heavy materials across vast distances. The builders of Nabta Playa were part of a much larger cultural sphere, one that encompassed much of what we now call the Eastern Sahara. Who were these ancient astronomers? The conventional archaeological interpretation sees them as the ancestors of the pharaonic Egyptians, pastoral peoples who developed astronomical knowledge to predict the seasonal floods of the Nile. But this explanation faces several challenges. Nabta Playa is located far from the Nile, in a region that was already becoming arid by the time the most sophisticated alignments were built. Its builders seem to have been motivated not by practical needs, like flood prediction, but by a purely scientific desire to understand the cosmos. The site's influence can be traced in later Egyptian astronomy. The constellation map at Nabta Playa shows Orion in the same configuration that appears in pyramid texts and tomb paintings thousands of years later. The precision measurement techniques evident in the stone alignments anticipate the mathematical accuracy of pyramid construction. The calendar systems encoded in Nabta C's stone arrangements provided the foundation for Egyptian timekeeping that remained accurate for millennia. Yet Nabta Playa itself was abandoned around 4,800 years ago, roughly coinciding with the final desiccation of the Sahara. Its builders vanished into the archaeological record, leaving behind only their stones and the astronomical knowledge that would later bloom in the Nile Valley. Whether they migrated east to join the Proto-Egyptian cultures or adapted in place to create oasis civilizations deeper in the desert, remains one of the great unsolved mysteries of African prehistory. Today, wind-blown sand is slowly burying the stone circles again, and the harsh desert sun is gradually eroding the megaliths that took such enormous effort to erect. But the achievement they represent humanity's first systematic attempt to understand our place in the cosmos continues to inspire and puzzle archaeologists who recognize in these ancient stones the birth of scientific thinking itself. High above the Sahara, sophisticated satellites equipped with sensors that can peer through sand and detect subtle variations in surface temperature orbit silently, revealing secrets that have remained hidden for millennia. This is the new frontier of archaeology, not the careful excavation of individual sites, but the systematic mapping of entire landscapes from space, where patterns invisible to ground-based observers emerge with startling clarity. The technology began as a military application during the Cold War, when intelligence agencies needed to see through camouflage and concealment to identify hidden installations. But what works for detecting buried bunkers also works for finding buried cities. Synthetic aperture radar, SAR, can penetrate several meters of dry sand, revealing the outlines of buried structures. Multispectral imaging detects subtle color variations that indicate different types of buried materials. Most remarkably, thermal infrared sensors can identify buried stone foundations because stone retains heat differently than the surrounding sand, creating temperature anomalies that persist for hours after sunset. Dr. Sarah Parcock of the University of Alabama, a pioneer in satellite archaeology, has used these techniques to map thousands of previously unknown archaeological sites across Egypt and the broader Middle East. Her work demonstrates the extraordinary sensitivity of modern remote sensing. From orbit, she can identify individual walls within buried buildings, distinguish between different types of construction materials, and even detect ancient roads and field systems that have been invisible for centuries. When these same techniques are applied to the deep Sahara, the results are extraordinary. Across Libya's Fezzan Basin, thermal imaging reveals geometric patterns spanning dozens of square kilometers, rectangles within rectangles, suggesting city blocks and districts laid out according to organized urban plans. In Chad's Borkou region, multispectral analysis shows linear features that stretch for hundreds of kilometers, following paths too straight and regular to be natural geological formations. Perhaps most intriguingly, ground-penetrating radar, GPR, surveys conducted at selected sites have confirmed that many of these satellite anomalies correspond to actual buried structures. At locations in Algeria and Libya, where orbital sensors detected subsurface patterns, ground-based radar has identified void spaces, density variations, and geometric formations consistent with human construction. The radar signatures suggest not just individual buildings, but extensive architectural complexes that might once have been major urban centers. The scale of these discoveries is staggering. Traditional archaeology focuses on individual sites, rarely covering more than a few hectares at a time. Satellite archaeology can survey entire regions in a single imaging pass, revealing the broader context that individual excavations miss. What emerges from this bird's-eye view is a picture of the ancient Sahara, far more densely populated and extensively developed than anyone had previously imagined. But satellite archaeology also reveals the fragility of the archaeological record. Time-lapse imagery shows how quickly desert sites can appear and disappear as shifting sands alternately bury and expose ancient remains. Structures that are clearly visible in satellite images from one year may be completely hidden in images taken just a few seasons later. This creates a race against time, not just against natural erosion, but against the constant movement of the sand itself. The political challenges are equally daunting. Many of the most promising sites lie in regions affected by ongoing conflicts or political instability. Libya, Chad, Sudan, and other Saharan nations have experienced decades of war and civil unrest that make systematic archaeological investigation extremely difficult. International research teams face not just logistical challenges, but genuine risks to personal safety that limit access to potentially crucial sites. Even where access is possible, the technical challenges of desert archaeology are formidable. Sites detected by satellite imagery often lie hundreds of kilometers from the nearest roads or settlements, requiring extensive logistical support for any ground investigation. The extreme climate makes fieldwork possible only during brief windows of moderate weather. Equipment fails regularly in the harsh conditions, and the remoteness of many sites means that repairs or replacements can take weeks to arrange. Yet the potential rewards justify these challenges. Dr. Parkhawk estimates that satellite surveys have identified over 3,000 previously unknown sites across the Sahara, representing a potential expansion of our knowledge of ancient African civilizations by several orders of magnitude. Each dot on our satellite maps represents a place where people lived, worked, built, and dreamed thousands of years ago, a piece of human history that has been waiting beneath the sand for the right technology to reveal it. The ultimate test will come when ground teams can finally reach these sites and confirm what the satellites suggest. Are the geometric patterns really the remains of ancient cities, or are they unusual geological formations that happen to create regular shapes? Do the thermal anomalies indicate buried buildings, or simply variations in soil composition? These questions can only be answered through old-fashioned archaeological excavation, but the satellite surveys provide the roadmap that makes such investigations possible. Meanwhile, high above the desert, the satellites continue their patient vigil, adding new discoveries to their growing catalog of buried secrets with each orbital pass. The transformation began subtly, perhaps noticed first by the astronomers at places like Nabda Playa, who tracked the subtle shifts in seasonal patterns across generations of careful observation. The summer rains that had sustained the green Sahara for 4 millennia began to arrive later, last for shorter periods, and deliver less water to the vast network of rivers and lakes that had made the desert bloom. What started as minor variations in weather gradually became a fundamental shift in climate, a change so profound that it would reshape the entire African continent and redirect the course of human civilization. The mechanisms driving this transformation operated on scales both vast and intimate. Earth's orbital parameters, the slow wobble of its axis, the gradual changes in its elliptical path around the sun shifted the monsoon patterns that had brought life to the Sahara. Over thousands of years, the zone of maximum solar heating moved southward, taking the tropical rains with it. The Sahara found itself increasingly in the rain shadow of a climate system that had sustained it for millennia. But climate change in the ancient world didn't happen overnight. The transition from green paradise to desert wasteland took over 2,000 years, unfolding slowly enough that human communities could adapt, at least initially. Archaeological evidence from sites across North Africa shows that Saharan cultures responded to the changing conditions with remarkable ingenuity. They dug deeper wells, developed more efficient water storage systems, and concentrated their settlements around the most reliable oases and springs. For perhaps 1,000 years, this adaptation strategy succeeded. Communities that had once spread across vast grasslands contracted into more compact settlements focused on permanent water sources. They developed new technologies for surviving in arid environments, improved pottery for water storage, more efficient irrigation systems, and architectural techniques suited to extreme heat and scarce rainfall. Some of these adaptations were so successful that they continued to support urban populations long after the surrounding landscape had become essentially uninhabitable. But technology has limits, and as the Sahara continued to dry, even the most sophisticated oasis communities found themselves facing impossible choices. Springs that had flowed for thousands of years began to fail. Rivers that had once supported navigation and extensive agriculture dwindled to seasonal streams, then to chains of isolated pools, and to nothing but dry wadis, marked only by the occasional flash flood. The archaeological record of this period is poignant in its detail. At site after site across the former Green Sahara excavations reveal the same pattern. Evidence of increasingly desperate attempts to maintain water supplies, followed by gradual abandonment, as the communities that had thrived for generations found themselves unable to sustain their populations in an environment that no longer offered sufficient resources for survival. Where did these people go? The conventional archaeological narrative focuses on migration to the Nile Valley, and certainly there is strong evidence for significant population movements in that direction. The cultural and technological similarities between late Green Sahara sites and early Egyptian developments suggest extensive contact and probably substantial migration. The astronomical knowledge, artistic traditions, and technical skills developed during the Green Sahara period all appear in early Egyptian civilization, transmitted by people who carried their expertise with them as they sought new homes in a changing world. But migration wasn't the only response. Some communities, particularly those controlling the most reliable water sources, chose to stay and adapt. These settlements gradually evolved into the oasis cities that would later become crucial nodes in trans-Saharan trade networks. Places like Ghat, Adams, and Timbuktu may trace their origins to Green Sahara communities that successfully managed the transition to desert conditions. Even more intriguingly, some evidence suggests that certain communities didn't just adapt to the changing climate, they thrived in it. The development of trans-Saharan trade during the post-Green period required extensive knowledge of desert navigation, water sources, and seasonal patterns that could only have been accumulated by people who had lived through the transition. The merchants and guides who made the Sahara a highway for continental commerce may have been the descendants of communities that chose to remain in their ancestral homeland despite its transformation. The skills these communities developed during the long transition from green paradise to desert would have been invaluable for creating sustainable settlements in increasingly arid conditions. Their knowledge of astronomy could predict seasonal changes and guide navigation across trackless wastes. Their expertise in water management could locate and exploit the deep aquifers that still underlie much of the Sahara. Their architectural traditions could create buildings designed to survive extreme heat, sandstorms, and the other challenges of desert life. These adaptation strategies might have supported substantial populations for centuries or even millennia after the Green Sahara ended. urban centers built around permanent oases, connected by trade routes maintained by people who knew every water source, and seasonal pattern across thousands of kilometers of desert could have created a civilization uniquely adapted to its harsh environment. Such settlements would have been vulnerable to the same forces that eventually buried the Roman ship in Chad, the relentless accumulation of wind-blown sand that characterizes the Sahara's most arid periods. But their ruins, preserved beneath the sand that destroyed them, might represent one of humanity's most remarkable experiments in adaptation to environmental change, a lesson in resilience that remains buried in the world's greatest desert. In the remote reaches of Libya's Gilf Khyber Plateau, where few human feet have trodden since the last caravans passed through centuries, UGO ground-penetrating radar has detected something that shouldn't exist: massive subsurface anomalies that display the geometric regularity of deliberate construction. The radar signatures suggest structures of extraordinary size, some over 100 meters in length, buried beneath dozens of meters of accumulated sand. What makes these discoveries particularly intriguing is their location in areas that mainstream archaeology considers to have been uninhabitable for thousands of years. Dr. Farouk Elbaz, the Egyptian-American geologist who helped select landing sites for the Apollo lunar missions, has applied the same remote sensing techniques he used to map the moon to the hidden landscape of the Sahara. His surveys have identified dozens of sites where subsurface structures create distinctive patterns in radar imagery, thermal photography, and magnetic field measurements. The largest of these anomalies, located in the Libyan desert near the Egyptian border, covers an area of nearly 20 square kilometers and shows internal organization that suggests a complex of interconnected buildings. The technical evidence is compelling. Ground-penetrating radar works by sending electromagnetic pulses into the ground and measuring the time it takes for them to bounce back from buried objects. Different materials, stone, sand, air-filled voids, reflect these pulses differently, creating distinctive signatures that can be interpreted by experienced analysts. When radar surveys detect large rectangular voids arranged in regular patterns, the most likely explanation is human construction, particularly when these patterns are associated with changes in soil chemistry and magnetic anomalies that suggest the presence of worked stone or metal artifacts. At the Abu Bawa site in Egypt's western desert, initial excavations conducted in the 1990s revealed the edge of what appeared to be a much larger buried complex. The exposed structures showed sophisticated stonework and architectural details that suggested religious or ceremonial functions. But the excavation was halted due to logistical challenges and security concerns, leaving the vast majority of the site unexplored. Radar surveys conducted years later suggested that the visible ruins represent only a tiny fraction of what lies beneath. The sand, possibly one of the largest archaeological complexes in Africa, buried but intact. The resistance from mainstream archaeology to these discoveries is understandable but frustrating to researchers, convinced of their significance. Dr. Zahi Hawass, former Secretary General of Egypt's Supreme Council of Antiquities, has expressed skepticism about claims of major buried sites in the deep desert. Extraordinary claims require extraordinary evidence, he argues. Radar anomalies and thermal signatures can be caused by many natural phenomena. Until we have actual excavation results showing artificial structures, we must remain cautious about interpreting these patterns as evidence of ancient cities. This skepticism is methodologically sound, but it creates a circular problem. The sites are so remote, and the excavation challenges so formidable, that gathering the extraordinary evidence required to convince skeptics may be practically impossible. The logistics of mounting major excavation projects hundreds of kilometers from the nearest infrastructure, in politically unstable regions where security cannot be guaranteed, exceed the resources of most archaeological institutions. The result is a standoff where potentially groundbreaking discoveries remain unconfirmed because they cannot be safely or affordably investigated. However, limited ground surveys at accessible sites have yielded tantalizing hints that support the satellite evidence. At several locations where radar anomalies suggested buried structures, surface reconnaissance has found scattered pottery sherds, worked stone fragments, and other artifacts that indicate human occupation. These surface finds are typically dismissed as evidence of temporary camps or small settlements, but their distribution patterns often correspond exactly to the subsurface anomalies, suggesting that the visible artifacts may be eroding from much larger buried sites. The most compelling evidence comes from sites where natural erosion has partially exposed buried structures. In Sudan's Bayuda Desert, wind scour has revealed the tops of stone walls that extend deep underground, following lines that correspond to rectangular patterns visible in satellite imagery. Similar partial exposures have been documented in Chad, Niger, and Algeria, suggesting that the subsurface anomalies detected by remote sensing may indeed represent extensive archaeological sites. Perhaps the most intriguing possibility is that these buried structures represent a type of architecture specifically adapted to desert conditions buildings, designed to be partially subterranean as protection against sandstorms and extreme temperatures. Many traditional Saharan communities build semi-underground structures for precisely these reasons, and ancient builders facing similar environmental challenges might have developed comparable solutions. If so, what appears to be burial by sand might actually be deliberate construction below ground level, preserved by the same environmental conditions that have hidden it from modern observation. The potential significance of these sites extends far beyond archaeology. If the radar anomalies do represent major urban centers, they would fundamentally alter our understanding of ancient African civilization, suggesting that complex societies existed in the Sahara long after it had supposedly become uninhabitable. They would provide crucial evidence for theories about the continuity between Green Sahara cultures and later Egyptian developments, potentially filling in one of the most significant gaps in our knowledge of human cultural evolution. But until political conditions allow for extensive excavation, or until new remote sensing technologies can provide more definitive evidence of artificial construction, the buried temples, if that's what they are, will remain among archaeology's most tantalizing mysteries, waiting beneath the sand for the right combination of technology, funding, and political stability to reveal their secrets. In 1922, archaeologist Leonard Woolley made a discovery in the Iraqi desert that changed our understanding of what sand can preserve. Excavating the ancient Sumerian city of Ur, his team uncovered the perfectly preserved body of Queen Pwabi, buried over 4,500 years ago. The extreme dryness of the desert environment had mummified her remains so completely that her gold jewelry still gleamed. Her elaborate headdress remained intact, and even delicate fabric from her clothing had survived nearly 5 millennia in pristine condition. This discovery revealed a fundamental truth about desert environments. While the harsh conditions make life nearly impossible, they also create perfect conditions for preservation. A combination of extreme dryness, stable temperatures, and sterile conditions prevents the bacterial decay that destroys organic materials in more humid environments. In the Sahara, this preservation potential reaches extraordinary levels, creating a vast natural museum where artifacts can survive for tens of thousands of years in conditions that would destroy them anywhere else on Earth. The evidence for this remarkable preservation capacity comes from discoveries scattered across the desert. In Egypt's western desert, excavations have uncovered wooden artifacts over 8,000 years old that are so well preserved they could have been made yesterday. Leather goods retain their flexibility, textiles maintain their original colors, and even delicate items like feathers and insects are found in perfect condition. The dry sand acts like a time capsule, freezing moments from the distant past in extraordinary detail. Perhaps even more remarkably, the desert preserves traces of activity that would disappear within days or weeks in other environments. In the Libyan Sahara, archaeologists have found human footprints preserved in hardened mud for over 100,000 years. These aren't just impressions in stone, they're actual footprints, complete with toe marks and heel prints, left by people walking across what was then a muddy lakeshore. The lack of vegetation, the absence of burrowing animals, and the protective coating of wind-blown sand combine to preserve these ephemeral traces of human presence across geological timescales. The Sahara ice preservation extends beyond human artifacts to include biological materials that provide crucial insights into ancient climates and ecosystems. Pollen grains buried in desert sediments retain their cellular structure for thousands of years, allowing paleoclimatologists to reconstruct the vegetation that existed during the Green Sahara period. Even more extraordinarily, DNA, extracted from these ancient sediments, has revealed the genetic signatures of plants and animals that lived in the region when it was still fertile, providing direct evidence of the ecological richness that once characterized the world's largest desert. This preservation potential has profound implications for archaeology in the Sahara. Unlike sites in temperate climates where organic materials decay within decades, Saharan archaeological sites may contain perfectly preserved examples of wooden tools, leather goods, textiles, foodstuffs, and even human remains that could provide unprecedented insights into ancient ways of life. The challenge is not preservation. The desert has already handled that, but access and discovery. The same conditions that preserve ancient materials also hide them. The constant movement of sand in the Sahara means that sites can be buried and exposed repeatedly over centuries, sometimes appearing at the surface for brief periods before being hidden again by shifting dunes. The Roman ship discovered in Chad illustrates this perfectly, preserved in pristine condition by the desert environment, but visible only because unusual wind patterns had temporarily scoured away the overlying sand. Satellite archaeology is beginning to reveal the full extent of what the desert has preserved. Thermal imaging can detect buried organic materials because they retain heat differently in surrounding sand, creating subtle temperature variations that sophisticated sensors can measure from orbit. Multispectral imaging can identify buried wood, leather, and other organic materials based on their distinctive spectral signatures. These techniques suggest that the Sahara may contain vast quantities of perfectly preserved ancient materials, most of it still waiting to be discovered. The preservation isn't limited to solid artifacts. In some locations, the desert has created natural archives of human activity that read like ancient newspapers. At the Mesic Plateau in Libya, rock surfaces preserve thousands of petroglyphs spanning over 12,000 years of human occupation. The extreme dryness has prevented weathering that would have erased these images anywhere else, creating a continuous record of human artistic expression across the entire period from the late Ice Age to the present. Even more remarkably, some desert sites preserve evidence of specific historical events. Archaeologists working in Egypt's eastern desert have found the remains of Roman mining camps, where everything from tools to administrative documents written on papyrus and leather have survived in readable condition. These sites provide detailed records of daily life in the ancient world, preserved by the same environmental conditions that made life there nearly unbearable. The implication is that the Sahara functions as a vast archaeological archive, containing perfectly preserved evidence of human activity spanning tens of thousands of years. The challenge for modern archaeology is developing the techniques and resources necessary to locate and safely excavate these treasures before shifting sands hide them again or human activities destroy them forever. Rising from the sandy plains of Mauritania, like a bullseye painted on the earth itself, the Reachit structure presents one of geology's most spectacular puzzles. Visible from space as a series of concentric circles nearly 50 kilometers across, this formation, known locally as the Eye of the Sahara, has captured imaginations and sparked controversies since it was first photographed by astronauts in the 1960s. But it's the structure's uncanny resemblance to ancient descriptions of Atlantis that has made it the focus of one of archaeology's as most intriguing modern mysteries. The geological consensus holds that the Richet structure is a natural formation created by the erosion of a geological dome. Over millions of years, wind and water carved away softer sedimentary layers, leaving behind the resistant rings of harder rock that create the circular pattern visible from orbit. This explanation is supported by rock samples showing sedimentary layers of different ages, mineral compositions that match known geological processes, and structural features consistent with natural erosion patterns. Yet the structure's almost perfect circularity continues to puzzle even mainstream geologists. Natural erosion typically produces irregular patterns that follow the varied resistance of different rock types and the random paths of water flow. The Richet structure's geometric precision is unusual enough that some researchers have proposed alternative explanations, including meteor impact, volcanic activity, or more exotic geological processes that might account for its remarkable symmetry. But it was the publication of several books in the early 2000s that brought the Richet structure to public attention as a possible location for Plato's Atlantis. The Greek philosopher's description of the lost continent included specific details that seemed to match the Mauritanian formation with startling accuracy. A circular city built on an island surrounded by concentric rings of water and land located beyond the Pillars of Hercules, possibly the Strait of Gibraltar, and destroyed by a catastrophic event that left it buried and forgotten. The parallels are striking enough to warrant serious consideration. Plato described Atlantis as having three circular zones, an inner island surrounded by alternating rings of land and water. The Richet structure shows exactly this pattern, concentric circles that could easily be interpreted as the remains of artificial barriers between water-filled moats. The dimensions also match Plato's account remarkably well. He described the central island as being about 50 stadia, roughly 9 kilometers, across, while the Richet structure's innermost ring measures approximately 12 kilometers in diameter. Even more intriguingly, the structure sits in a region that would have been much more hospitable during the Green Sahara period. Geological surveys show that the area was crossed by several major rivers during the African humid period, and satellite imagery reveals the traces of ancient lake beds in the surrounding region. A civilization building in this location 10,000 years ago would have had access to abundant water, fertile soils, and strategic position, controlling trade routes between sub-Saharan Africa and the Mediterranean world. Proponents of the Richet Atlantis theory point to several archaeological anomalies in the surrounding region that might support their interpretation. Ground surveys have found scattered artifacts, including worked stone, pottery fragments, and what appear to be the remains of ancient settlements. While these finds are dismissed by mainstream archaeologists as evidence of much later Berber or Arab occupation, some researchers argue that they could represent the debris from a much older and more significant civilization. The most compelling evidence comes from geological analysis of the structure itself. Recent studies have identified evidence of significant water flow through the Richet Formation during the Holocene period, including mineral deposits that suggest the presence of large bodies of standing water within the circular features. If the rings could hold water during the Green Sahara period, then Plato's description of alternating rings of land and water becomes much more plausible. However, the Atlantis hypothesis faces several major challenges. The primary problem is chronological. Plato dated the destruction of Atlantis to approximately 9,600 BCE, which predates the Green Sahara period by several thousand years. If the Richet structure was Atlantis, it would have been located in the middle of a hyperarid desert during the time period Plato specified, making it virtually impossible for a major civilization to have developed there. Dr. Robert Schoch of Boston University, a geologist who has studied the structure extensively, argues that while the Richet Formation is geologically fascinating, there is no credible evidence for human construction on the scale that would be required for Plato's Atlantis. The structure is entirely consistent with natural geological processes, he notes. Extraordinary claims require extraordinary evidence, and that evidence simply doesn't exist. Nevertheless, the mystery of the Richat structure continues to generate research and speculation. New remote sensing techniques are revealing previously unknown details about the formation structure and history, including evidence of complex water flow patterns and mineral deposits that weren't apparent in earlier studies. Some of these discoveries have reignited interest in the possibility that the structure might have played host to significant human activity during the Green Sahara period, even if it wasn't the legendary Atlantis itself. Whether the Eye of the Sahara represents a natural geological wonder, the remains of a lost civilization, or something else entirely may ultimately depend on future archaeological investigations that can definitively establish whether human beings ever built permanent settlements within its enigmatic rings. Until then, the Richat structure remains one of the most visually stunning and intellectually provocative features on the African continent. A perfect circle of mystery, inscribed in stone on the world's largest canvas of sand. Across the ancient Sahara, scattered among the rock art galleries and abandoned settlements of the Green period, lies evidence of an obsession that transcended practical concerns, the precise tracking of celestial movements. From Nabda Playa in Egypt to the Air Mountains of Niger, from the Tassili Plateau in Algeria to the Tibesti Range in Chad early, Saharan cultures created astronomical monuments that reveal a sophisticated understanding of celestial mechanics and a deep commitment to monitoring the rhythms of the cosmos. This astronomical knowledge wasn't merely academic. In societies that depended on seasonal rains, accurate prediction of weather patterns could mean the difference between prosperity and starvation. The star watchers of the ancient Sahara developed calendar systems of remarkable precision, tracking not just the annual cycle of seasons, but the subtle long-term changes in celestial patterns that unfold over centuries and millennia. At the Nabda Playa site, the stone circles contain alignments that track the precession of the equinoxes, the slow wobble in Earth's rotational axis that causes the positions of stars to shift gradually over a 26,000-year cycle. Creating such alignments requires not just advanced mathematical knowledge, but institutional continuity across many generations. The implications are staggering. These weren't nomadic peoples making temporary camps, but organized societies with permanent leadership structures and specialized knowledge keepers who maintained astronomical observations across centuries. The most intriguing aspect of Saharan astronomy is its consistency across vast distances and long periods of time. Similar astronomical alignments appear at sites separated by thousands of kilometers, suggesting either extensive communication networks or shared cultural traditions that spread across the entire Green Sahara. Star maps carved into rock faces in Niger show the same constellation patterns that appear in stone arrangements in Egypt. Calendar systems evident in Chad correspond to seasonal markers found in Algeria. Dr. Eureka Holbrook of the University of the Western Cape, who studies African astronomical traditions, argues that this consistency points to something unprecedented in ancient Africa, a unified astronomical culture that spanned continental distances. What we're seeing in the Saharan astronomical sites isn't just local knowledge, she explains. It's evidence of systematic observation and record-keeping on a scale that suggests formal institutions dedicated to studying the sky. But perhaps the most remarkable discovery is the apparent correlation between astronomical sites and the subsurface anomalies detected by modern satellite surveys. When the locations of known astronomical monuments are plotted against the positions of suspected buried settlements, patterns emerge that suggest deliberate coordination between skywatching and urban planning. Many of the largest subsurface anomalies lie at precisely the distances and directions from astronomical sites that would be required to create extended alignment systems spanning dozens or even hundreds of kilometers. This raises the extraordinary possibility that the scattered astronomical monuments of the Green Sahara weren't isolated observatories, but components of an integrated system designed to track celestial movements across an entire continental region. Such a system would have required not just astronomical knowledge, but sophisticated surveying techniques to establish precise alignments across vast distances. The builders would have needed to create permanent markers visible from great distances, coordinate observations between widely separated sites, and maintain consistent measurement systems across their entire network. The technical challenges of creating such a system would have been enormous. Establishing sight lines across hundreds of kilometers of varied terrain requires advanced knowledge of optics and surveying. Coordinating observations between distant sites demands reliable communication systems and standardized measurement techniques. Most fundamentally, the entire enterprise would require levels of social organization and resource allocation typically associated with major urban civilizations. Archaeological evidence from several Saharan astronomical sites supports this interpretation. At the Nabta Playa complex, excavations have revealed not just the famous stone circles, but evidence of associated settlements that show signs of specialization and craft production. The pottery found at the site includes sophisticated ceremonial vessels decorated with astronomical motifs. Tools and weapons show evidence of advanced metallurgy and trade connections spanning thousands of kilometers. Similar patterns appear at other astronomical sites across the Sahara. The Air Mountains in Niger contain not just astronomical alignments, but evidence of associated settlements that supported specialized craftsmen, traders, and presumably the astronomer priests who maintained the sky-watching traditions. Rock art at these sites shows not just astronomical knowledge, but evidence of complex social hierarchies and ceremonial practices that suggest organized religious or scientific institutions. The implications go far beyond astronomy. If the ancient Sahara supported a network of sky-watching sites coordinated across continental distances, then the societies that created and maintained this system possessed levels of organization, communication, and technical sophistication that approach those of the earliest urban civilizations elsewhere in the world. They had developed methods for precise measurement and long-distance coordination that would be out of place in a modern scientific project. Most intriguingly, the astronomical knowledge preserved in Saharan sites appears to have influenced later developments in Egypt and beyond. The precision calendar systems, constellation maps, and architectural alignment techniques that appear in pharaonic Egypt can all be traced back to earlier Saharan prototypes. This suggests that the sky builders of the Green Sahara weren't just local innovators, but pioneers whose discoveries provided the foundation for some of humanity's most enduring achievements in astronomy and architecture. The scattered stone circles and astronomical alignments that dot the modern Sahara may represent the visible remnants of humanity's first continental-scale scientific project, an attempt to map the cosmos that required levels of coordination and institutional organization that we're only beginning to understand. Beneath the sand that has buried their cities, the star maps of the ancient Sahara may still preserve the records of this remarkable achievement. Beneath the shifting dunes of the Sahara, ground-penetrating radar has revealed the ghostly outlines of a transportation network that once spanned continents. These aren't merely ancient paths worn by countless feet and hooves, but engineered roadways complete with raised causeways, drainage systems, and way stations that suggest a level of infrastructure planning comparable to the great highway systems of Rome and China. The scale of this buried network is breathtaking. Satellite imagery shows linear features stretching for hundreds of kilometers across regions that have been lifeless desert for millennia. These lines are too straight and regular to be natural formations, too extensive to be coincidental, and too precisely aligned to be anything other than deliberate human construction. They connect points that radar surveys suggest were once major settlements, following routes that minimize elevation changes and avoid natural obstacles with the precision of modern highway engineering. Dr. David Mattingly of Leicester University, who whose team has mapped extensive ancient road networks in Libya, describes these discoveries as potentially revolutionary for our understanding of ancient African transportation systems. His ground surveys of partially exposed sections have revealed sophisticated construction techniques: stone foundations laid on prepared roadbeds, drainage channels to prevent water damage, and regular spacing of what appear to be way stations or supply depots. The engineering represents a massive investment in infrastructure. Building roads across desert terrain requires moving enormous quantities of stone and earth. Sophisticated knowledge of drainage and foundation techniques, and the organizational capacity to coordinate construction across vast distances. Such projects demand not just skilled engineers and large labor forces, but surplus economies capable of supporting extensive public works projects that provide no immediate return on investment. But perhaps the most remarkable aspect of this buried road network is its relationship to the ancient lake systems that once dotted the Sahara. Paleoclimatic research has identified the locations of over 200 major lakes that existed during the Green Sahara period, some as large as modern seas. The buried roadways don't simply connect scattered settlements, they link the former shorelines of these vanished lakes in patterns that suggest comprehensive planning for both land and water transportation. At Lake Mega Chad, which once covered an area larger than the modern Caspian Sea, satellite analysis reveals what appears to be an extensive network of harbors and port facilities connected by causeways that extend deep into what was once open water. The engineering challenges of building in such environments would have been formidable, requiring techniques for driving pilings through lake sediments, creating artificial islands to support harbor structures, and building causeways capable of withstanding seasonal flooding and wave action. The evidence suggests that ancient Saharan engineers didn't just adapt to their aquatic environment, they mastered it. Sonar surveys of modern Lake Chad, a remnant of the much larger ancient lake system, have detected regular geometric patterns on the lake floor that correspond to suspected harbor sites visible in satellite imagery. These patterns suggest permanent structures built to withstand submersion during high water periods and exposure during seasonal droughts. Ground-penetrating radar surveys along the suspected road alignments have revealed associated infrastructure. That speaks to sophisticated logistics planning. At regular intervals corresponding to days' march distances, radar detects clusters of structures that appear to be way stations or supply depots. These sites show evidence of water storage facilities, what might be stables or corrals for pack animals, and sleeping quarters for travelers. The consistency of spacing and design suggests standardized planning across the entire network. The most intriguing discoveries come from the intersection points where multiple road systems converge. At these locations, satellite imagery and radar surveys reveal extensive architectural complexes that dwarf anything else detected in the buried Saharan landscape. These sites appear to have been major urban centers positioned to control transportation. Networks spanning thousands of kilometers, ancient equivalents of cities like Damascus or Samarkand that grew wealthy by controlling crucial trade routes. But this infrastructure network faced the same climatic catastrophe that destroyed the Green Sahara itself. As the lakes began to shrink and the rivers failed, the transportation system that had linked a continent became increasingly difficult to maintain. Way stations that had once provided reliable water for travelers found their wells running dry. Harbors that had serviced extensive lake traffic found themselves stranded kilometers from receding shorelines. Archaeological evidence suggests that some communities attempted to maintain the road network even as their environment collapsed around them. At several partially excavated sites, archaeologists have found evidence of extensive modifications to original structures, suggesting attempts to adapt harbor facilities for use as oasis settlements and to convert lakeside way stations into desert trading posts. These adaptation efforts may have succeeded for centuries, creating the oasis trading centers that would later become crucial nodes in trans-Saharan commerce. The buried road network may also explain one of the great mysteries of African prehistory: how technological innovations and cultural practices spread so rapidly across such vast distances during the Green Sahara period. Pottery styles, metalworking techniques, astronomical knowledge, and artistic traditions show remarkable consistency across regions separated by thousands of kilometers, suggesting extensive communication and trade networks that conventional archaeological models have struggled to explain. If the radar anomalies do represent the remains of a continental-scale transportation infrastructure, they would fundamentally alter our understanding of ancient African civilization. They would demonstrate that Saharan cultures possessed not just the technical knowledge necessary for large-scale engineering projects, but the social organization and economic resources to implement and maintain infrastructure systems comparable to those of the great ancient empires. Today, these buried highways lie silent beneath the sand, their precise engineering gradually succumbing to the erosive forces that claimed the cities they once connected. But in their ghostly outlines, visible only to satellite sensors and ground-penetrating radar, we can still trace the roots that may have carried the first continental-scale commerce in human history. In Niger's Tenor Desert, where even the hardy Tuaregs speak of the landscape with respect bordering on fear, archaeologist Paul Sereno made a discovery that challenged fundamental assumptions about how ancient peoples lived in harsh environments. Working at a site called Gobero, his team uncovered evidence of human occupation spanning over 5,000 years, but not in the way archaeologists expected. Instead of finding the remains of a static settlement, they discovered something far more remarkable: traces of a community that literally moved with the shifting sands, adapting its urban plan to track the changing position of dunes and water sources across millennia. The initial discovery seemed straightforward enough. Gobero contained multiple layers of occupation, with newer settlements built directly on top of older ones in a pattern familiar from archaeological sites worldwide. But as Sereno's team carefully mapped the relationship between different occupation levels, an extraordinary pattern emerged. The successive settlements weren't just rebuilt in the same location. They followed a precise trajectory across the landscape, moving steadily eastward at a rate that corresponded exactly to the advance of a massive dune system. What we found challenged every preconception about ancient urbanism, Sereno explains. These people weren't building a city in one place and defending it against environmental change. They were creating a mobile urban environment that moved in harmony with the landscape itself. The evidence was preserved in remarkable detail. Each occupation layer showed the same basic urban plan: a central area with larger structures surrounded by smaller residential buildings, areas set aside for craft production, and burial grounds placed at consistent distances from the living areas. But this plan wasn't rigidly fixed, it was systematically modified for each move, with buildings repositioned to take advantage of new water sources, to avoid unstable sand formations, or to optimize relationships with changing wind patterns. The technical sophistication required for such systematic urban mobility would have been extraordinary. Moving an entire community required not just logistical planning on a massive scale, but predictive knowledge of environmental changes that might not become apparent for decades. The builders of mobile Gobero needed to understand sand dune migration patterns, seasonal changes in wind direction, long-term shifts in groundwater availability, and dozens of other environmental variables that determine where urban settlement is viable in desert conditions. Carbon dating revealed that this mobile urbanism persisted for over 50 generations, suggesting that the knowledge and organizational systems necessary to coordinate community-wide relocations were successfully transmitted across centuries. Each generation inherited not just the technical skills needed for desert survival, but institutional knowledge about how to plan and execute the systematic movement of an entire urban population. The artifacts found at successive occupation levels show increasing sophistication over time, suggesting that mobile urbanism didn't represent adaptation to decline, but rather a successful urban strategy that, supported growing prosperity and cultural complexity. Pottery became more elaborate, metalworking more sophisticated, and trade connections more extensive as the community perfected its mobile lifestyle. By the final occupation periods, artifacts found at Gobero show trade connections spanning thousands of kilometers, indicating that mobile urbanism was compatible with extensive commercial networks. Perhaps most remarkably, the burial practices at Gobero show that community identity persisted across all the relocations. Successive generations maintained the same basic funeral traditions, burial orientations, and grave goods despite repeated moves across dozens of kilometers. This suggests that the mobile community preserved not just its practical survival strategies, but its cultural traditions, social hierarchies, and spiritual practices across centuries of environmental adaptation. The implications extend far beyond a single site in Niger. If communities like Gobero could successfully implement mobile urban strategies, then many of the subsurface anomalies detected across the Sahara might represent not single buried cities, but traces of multiple settlements created by communities that moved systematically across the landscape as environmental conditions changed. This would explain why some radar signatures show overlapping architectural patterns that do not conform to conventional urban planning models. Mobile urbanism might also explain the rapid spread of technological and cultural innovations across the ancient Sahara. Communities that moved regularly would have served as vectors for transmitting knowledge, techniques, and artistic traditions across vast distances, much more efficiently than static settlements dependent on occasional long-distance trade contacts. A network of mobile communities could have created the continent-spanning cultural connections evident in green Sahara archaeological sites. The final occupation at Gobero ended around 4,500 years ago, as the Sahara's desiccation reached levels that made even mobile desert urbanism unsustainable. But the community's disappearance doesn't necessarily mean its complete extinction. The skills developed during 5,000 years of successful mobile urbanism, knowledge of desert navigation, water location, sustainable resource management, and community organization would have been invaluable for survival in the increasingly arid post-green Sahara. Today, wind scour occasionally exposes sections of Gobero's successive occupation levels, revealing glimpses of this remarkable experiment in environmental adaptation. The site stands as testament to human ingenuity in the face of environmental challenge, and as a reminder that our ancestors' responses to climate change were often far more sophisticated and successful than we might assume. In the traces of the city that moved with the sand, we can see reflections of both ancient wisdom and future possibilities for living sustainably in a changing world. In the austere conference rooms of archaeological institutions around the world, where careers are built on careful methodology and rigorous peer review, claims about buried Saharan cities receive the kind of skeptical scrutiny that has long protected scientific discourse from sensational speculation. The resistance isn't born of closed-mindedness or professional jealousy, but from hard-earned wisdom about how easy it is to see patterns where none exist, to interpret natural phenomena as evidence of human activity, and to let wishful thinking overwhelm careful analysis. Dr. Zahi Hawass, the former Secretary General of Egypt's Supreme Council of Antiquities, has spent decades evaluating claims about lost civilizations and hidden archaeological treasures. His approach to the Saharan anomalies reflects the cautious methodology that has served archaeology well. Every year, someone claims to have found Atlantis, or a lost pyramid, or a buried city. The satellite images are interesting. The radar data are intriguing. But archaeology is built on excavation and analysis, not speculation and remote sensing. Until we have artifacts in our hands and structures we can measure and study, these remain unproven hypotheses. This skepticism is reinforced by the history of archaeological false alarms in desert environments. Ground-penetrating radar is notoriously prone to misinterpretation in sand-covered terrain, where variations in soil density, mineral content, and moisture levels can create patterns that look artificial but are entirely natural. Thermal imaging from satellites can be fooled by buried rock formations, ancient lava flows, or simple variations in sand composition that have nothing to do with human construction. The burden of proof in archaeology is deliberately high, and for good reason. The field has a long history of spectacular mistakes based on insufficient evidence. Heinrich Schliemann has destructive excavations at Troy, which destroyed crucial archaeological layers in pursuit of Homer's legendary city. The Piltdown Man hoax, which misled anthropologists for decades. And countless smaller errors, where natural formations were initially interpreted as human constructions before more careful analysis revealed their true nature. Professor David Mattingly of Leicester University, whose team has conducted extensive archaeological surveys across the Sahara, emphasizes the practical challenges that limit definitive investigation of the suspected sites. The remote sensing data are genuinely intriguing, but the logistics of proper excavation in these locations are staggering. We're talking about sites hundreds of kilometers from the nearest infrastructure, in regions where political instability makes long-term research projects extremely dangerous. Without the ability to conduct proper excavations, we simply can't evaluate these claims scientifically. The methodological requirements for proving the existence of ancient urban centers are stringent and expensive. Proper archaeological excavation requires teams of specialists, sophisticated equipment, laboratory analysis of samples, and years of careful work to establish the age, function, and cultural context of buried structures. The cost of mounting such expeditions to remote Saharan locations could easily exceed $1 million per site, with no guarantee that the subsurface anomalies represent anything more significant than unusual geology. Furthermore, mainstream archaeologists point out that the conventional interpretation of ancient Saharan cultures as primarily nomadic is supported by decades of careful excavation and analysis at accessible sites throughout North Africa. The material culture recovered from these sites, portable pottery, temporary shelters, evidence of seasonal mobility, all support the model of pastoral societies adapted to environmental variability rather than permanent urban settlements. Dr. Elena Garcia of the University of Casino, who has spent her career studying Saharan prehistory, argues that the absence of urban centers is actually evidence of sophisticated environmental adaptation. These were highly successful societies precisely because they remained mobile. The environmental constraints of the Sahara, even during its green period, favored flexibility and adaptation over permanent settlement. The absence of major urban centers doesn't indicate cultural poverty. It indicates intelligent adaptation to challenging conditions. The resistance also reflects legitimate concerns about the commercialization of archaeology and the tendency for speculative theories to attract media attention and funding at the expense of more careful, methodical research. Sensational claims about lost civilizations generate headlines and documentary contracts, while the patient work of mapping pottery distributions and analyzing pollen samples, the foundation of real archaeological knowledge, struggles for recognition and funding. However, even skeptical archaeologists acknowledge that the sheer scale of the Sahara and the political difficulties of access mean that vast areas remain essentially unexplored. Dr. Hawass himself admits it is entirely possible that significant sites exist in areas we have not been able to investigate properly. The question is whether the evidence justifies the extraordinary claims being made. The current standoff between satellite archaeology and traditional excavation methodology reflects a broader tension in contemporary archaeological practice. New technologies offer unprecedented opportunities to identify potential sites and plan research strategies, but they cannot replace the careful excavation and analysis that remain the foundation of archaeological knowledge. The challenge is developing research strategies that can take advantage of remote sensing capabilities while maintaining the rigorous standards that protect archaeology from speculation and fraud. Meanwhile, time is running out for many potentially significant sites. Military conflicts, industrial development, and climate change are destroying archaeological sites faster than researchers can investigate them. The luxury of waiting for perfect conditions and unlimited funding may not exist, forcing the archaeological community to develop new approaches that can extract maximum information from limited access and resources. The buried secrets of the Sahara will ultimately be resolved not by debate in conference rooms, but by the painstaking work of excavation in some of the most challenging field conditions on Earth. Until then, the tension between reasonable skepticism and tantalizing possibility continues to drive one of archaeology's most compelling ongoing mysteries. Across North Africa, scattered among the surviving fragments of oral tradition and carved into rock faces worn smooth by millennia of desert wind, stories persist that echo the same haunting themes. Great waters that once covered the land, cities that sank beneath rising floods, peoples who fled from catastrophic changes that transformed paradise into wasteland. These aren't merely local legends. They form part of a vast tapestry of memory that spans continents and cultures, suggesting that humanity's deepest myths may preserve actual recollections of geological catastrophes that shaped our species' early history. The flood narratives of North African cultures show remarkable consistency despite their geographical and cultural diversity. Berber traditions speak of a time when the ancestors lived beside great inland seas, until the waters either receded into the earth or were swallowed by encroaching sands. Tuareg legends tell of cities that once stood on islands in vast lakes, their inhabitants forced to flee when the waters failed and the desert claimed their homeland. Even cultures from the Sahara's periphery, Nubians along the Nile, Fulani in West Africa, preserve stories of ancestral migrations from lands that were lost to environmental catastrophe. These oral traditions often include startlingly specific details that correspond to geological evidence about the Sahara's climatic history. The Dogon people of Mali, famous for their astronomical knowledge, maintain detailed accounts of how their ancestors lived beside a great river that flowed northward across the continent before disappearing underground. This description matches precisely the course of the ancient Tamanrasset River system, which modern geology has reconstructed from satellite imagery and ground surveys. Similarly, the Tuareg preserved traditional route maps that mark the locations of water sources and landmarks that correspond to no features visible in the modern landscape. When geologists compare these traditional maps to reconstructions of the green Sahara's hydrography, the correlations are often exact. Springs marked in oral tradition correspond to locations where ground-penetrating radar has detected buried water sources. Routes described in traditional stories follow the courses of ancient rivers now visible only in satellite imagery. The persistence of these traditions across thousands of years suggests they preserve genuine historical memories, transmitted through oral culture with remarkable fidelity. Anthropologists studying oral tradition have documented the ability of some cultures to maintain accurate historical accounts across dozens of generations, particularly when those accounts relate to catastrophic events that fundamentally altered their ancestors' way of life. But the flood stories of North Africa don't just describe environmental change. They also preserve memories of human responses to that change. Many traditions include detailed accounts of technological adaptations, architectural innovations, and social reorganizations that allowed communities to survive as their environment transformed around them. The Ahadjar Tuareg, for instance, maintain oral histories describing how their ancestors learned to build underground water storage systems, develop new navigation techniques for trackless desert terrain, and create portable architectural forms that could be moved as conditions changed. These technological memories often include details that correspond to archaeological evidence from transitional sites where green Sahara cultures adapted to increasing aridity. Traditional accounts describe the construction of deep wells, sophisticated water management systems, and architectural techniques specifically adapted to desert conditions, all of which appear in the archaeological record from the period when the Sahara was transforming from savanna to desert. Perhaps most intriguingly, some oral traditions preserve what appear to be memories of urban centers that were deliberately abandoned and buried as environmental conditions became untenable. The Tibu people of the Central Sahara maintain stories about ancestors who sealed their cities beneath the sand to preserve them from destruction, creating hidden caches of knowledge and treasure that will be revealed when the time is right. These accounts describe systematic burial of buildings, careful concealment of entrances, and the establishment of secret markers that would allow future generations to relocate the hidden sites. Similar traditions appear among other Saharan peoples, often including specific geographical references that correspond to locations where satellite archaeology has detected subsurface anomalies. The consistency of these accounts across different cultures and regions suggests they might preserve actual memories of deliberate site abandonment and concealment rather than simply mythological accounts of lost civilizations. Rock art galleries across the Sahara provide visual confirmation of many details preserved in oral tradition. Petroglyphs and cave paintings show the environmental changes that oral accounts describe. Scenes of abundant water and vegetation giving way to increasingly arid conditions. Depictions of human communities adapting their lifestyles to changing conditions. And images that appear to document the gradual abandonment of settled communities in favor of mobile desert survival strategies. The astronomical knowledge embedded in many North African oral traditions also corresponds to archaeological evidence from ancient Saharan observatory sites. Traditional calendars maintained by Tuareg and other desert peoples preserve the same precision astronomical calculations evident in stone alignments at sites like Nabta Playa, suggesting continuity of knowledge transmission across thousands of years. Modern ethnographies, working with elderly traditional knowledge keepers, report that some communities still maintain oral maps that include references to buried cities and hidden water sources in regions that have been uninhabitable desert for millennia. While much of this traditional knowledge has been lost as Saharan communities have adapted to modern lifestyles, fragments persist that may provide crucial clues for locating and interpreting the archaeological sites that satellite surveys continue to discover. The convergence of oral tradition, geological evidence, and archaeological discovery suggests that the stories preserved in North African cultures aren't merely mythological accounts of imaginary golden ages, but authentic historical memories of real environmental catastrophes and human adaptations. In the persistent echoes of these ancient memories, we may find not just entertainment or cultural curiosity, but actual guidance for understanding one of the most significant chapters in human environmental history. Imagine the Sahara not as a wasteland, but as humanity's greatest archive, a vast natural library where each grain of sand is a page in an encyclopedia of civilizations, each dune a chapter in the story of our species' earliest experiments with urban life. This is not mere poetic metaphor, but an increasingly literal description of what satellite archaeology and ground-penetrating radar are, revealing beneath the world's largest desert. The same forces that destroyed ancient Saharan cities also preserve them, creating a unique archaeological resource that may contain the most complete record of early human urbanism on Earth. The preservation conditions in the Sahara are unmatched anywhere else on the planet. The extreme dryness that makes the desert hostile to life also prevents the bacterial decay that destroys organic materials in more humid environments. Wooden artifacts survive for thousands of years in perfect condition. Textiles retain their original colors and textures. Even delicate items like paper, leather, and organic pigments can survive for millennia in conditions that would destroy them within decades elsewhere. This preservation extends beyond individual artifacts to entire urban environments. In Egypt's western desert, archaeologists have found Roman-era settlements where wooden doors still hang on their hinges, where pottery sits on shelves exactly as it was left when the inhabitants departed, where even footprints in dried mud remain clearly visible after 1,500 years. If such perfect preservation is possible for relatively recent sites, imagine what might remain from settlements that were buried during the Green Sahara period thousands of years earlier. The scale of potential preservation is staggering. Satellite surveys suggest that subsurface anomalies cover thousands of square kilometers across the desert, representing possible archaeological sites that dwarf anything currently known from the ancient world. If even a fraction of these anomalies represent actual settlements, the Sahara may contain more intact ancient urban architecture than all of Egypt has currently known archaeological sites combined. But this buried library faces constant threats from the same forces that created it. The sand that preserves ancient sites also moves constantly, exposing and reburying structures in endless cycles that can destroy in decades what survived for millennia. Wind erosion, while slower than other forms of weathering, gradually wears away exposed surfaces, erasing inscriptions and architectural details that could provide crucial insights into ancient cultures. Modern development poses additional risks. Military activities, mining operations, and infrastructure projects increasingly penetrate previously remote desert regions, often without archaeological oversight that could identify and protect significant sites. The political instability that affects much of the Sahara makes systematic archaeological protection extremely difficult, leaving invaluable sites vulnerable to destruction by conflict, looting, or simply ignorance of their significance. Climate change adds another layer of threat. Increasing temperatures and changing precipitation patterns are altering the desert's preservation conditions, potentially accelerating decay processes that have been stable for millennia. Flash flooding, increasingly common as weather patterns become more extreme, can expose and then rapidly destroy sites that survived thousands of years of gradual environmental change. The challenge for modern archaeology is developing techniques that can extract maximum information from brief opportunities for investigation. Traditional excavation methods, designed for accessible sites where work can continue for years or decades, are poorly suited to remote desert locations where access may be possible only for short periods under dangerous conditions. New approaches that combine satellite imagery, ground-penetrating radar, and rapid assessment techniques may be necessary to document significant sites before they are lost to natural forces or human activities. Some researchers are pioneering virtual archaeology, approaches that attempt to reconstruct entire sites from remote sensing data without traditional excavation. While these techniques can't replace careful archaeological analysis, they may provide the only opportunity to document sites that are inaccessible for physical investigation. Advanced computer modeling can extrapolate complete architectural plans from partial radar signatures, create three-dimensional reconstructions of buried structures, and even simulate how ancient settlements might have functioned based on their physical layouts. The potential rewards justify these innovative approaches. If the subsurface anomalies detected across the Sahara do represent extensive urban settlements, they could revolutionize our understanding of human social development, technological innovation, and environmental adaptation. They might contain the oldest examples of urban planning, the earliest evidence of complex governmental systems, and the most complete records of how human societies responded to major environmental changes. Perhaps most importantly, the buried cities of the Sahara might preserve knowledge that could be invaluable for addressing modern challenges. Ancient Saharan communities successfully created sustainable urban settlements in extreme environments, developed technologies for managing scarce water resources, and maintained complex civilizations through periods of dramatic climate change. The techniques they developed might provide crucial insights for creating sustainable cities in an era of global environmental change. The sand-covered library of the Sahara contains stories that could reshape our understanding of human civilization itself. Each buried settlement represents chapters in humanity as longest and most important experiment, learning to live together in complex societies while adapting to the challenges of a changing planet. The question is whether we can develop the technologies, funding, and political stability necessary to read these ancient texts before the desert claims them forever. Time is running out for many potentially crucial sites. Every year, military conflicts, industrial development, and natural erosion destroy archaeological evidence that took thousands of years to accumulate. The window for investigating the Sahara's buried cities may be measured in decades rather than centuries. Whether future generations will thank us for preserving this unprecedented archaeological resource or curse us for allowing it to be lost may depend on decisions made in research institutions and government offices today. In laboratories around the world, scientists are developing technologies that could finally unlock the secrets buried beneath the Sahara's sands. Artificial intelligence systems now analyze satellite imagery with superhuman precision, identifying subtle patterns that human eyes might miss entirely. Quantum sensors can detect gravitational anomalies created by buried structures, while advanced ground-penetrating radar can peer through dozens of meters of sand to create detailed three-dimensional maps of hidden architecture. For the first time in human history, we possess tools sophisticated enough to locate and analyze ancient cities without disturbing a single grain of sand above them. The European Space Agency's newest Earth observation satellites carry sensors capable of detecting differences in surface temperature of less than 1/10 of a degree, precise enough to identify buried stone foundations by the way they absorb and release heat differently than surrounding sand. NASA's SRTM program has created topographic maps so detailed they can reveal the subtle surface variations that indicate buried structures, while commercial satellite companies now offer imagery with resolution fine enough to distinguish individual stones in archaeological sites. Machine learning algorithms trained on known archaeological sites can now scan thousands of square kilometers of satellite imagery in hours, automatically flagging locations where subsurface patterns suggest human construction. These AI systems don't just identify obvious geometric shapes. They can recognize the subtle signatures of ancient urban planning, the telltale patterns of organized settlement that distinguish cities from natural formations. Dr. Sarah Parkek, whose work has already identified thousands of previously unknown sites across Egypt and the broader Middle East, describes the current moment as revolutionary for archaeology. We're moving from an era where discovering a new site was a matter of luck or intuition to one where we can systematically map human settlement patterns across entire continents. The Sahara, which has been archaeology's last great frontier, is finally yielding its secrets. But technology alone cannot solve the fundamental challenges that have kept the Sahara's buried cities hidden. Political instability across much of the region continues to make systematic archaeological investigation extremely dangerous. Libya, Chad, Sudan, Mali, and other nations that contain potentially crucial sites have experienced decades of conflict that make long-term research projects nearly impossible. International research teams face not just logistical challenges, but genuine risks to personal safety that limit access to the most promising locations. The financial requirements are equally daunting. Properly investigating even a single buried city could cost tens of millions of dollars, requiring not just archaeological expertise, but logistical support comparable to military expeditions. Transportation to remote sites, security arrangements, equipment to survive extreme climate conditions, and communication systems to maintain contact with the outside world all require resources far beyond those available to typical archaeological projects. Nevertheless, several ambitious projects are moving forward despite these challenges. The European Research Council has funded a consortium of universities to develop new techniques for non-invasive archaeology, specifically designed for Saharan conditions. Their goal is to create comprehensive maps of buried settlements using only satellite and airborne sensors, providing detailed enough information to understand ancient urban patterns without requiring ground excavation. Private funding is also entering the field, as technology entrepreneurs recognize the potential significance of Saharan archaeology. Google's Cultural Institute has provided funding for satellite surveys of promising sites, while other technology companies are developing specialized equipment designed specifically for extreme environment archaeology. The combination of commercial satellite services, artificial intelligence, and private funding could provide resources for Saharan archaeology that government agencies have been unable to supply. International cooperation offers another path forward. The African Union has proposed creating multinational archaeological zones in the Sahara, similar to the international scientific stations that operate in Antarctica. Such arrangements could provide the political stability and security guarantees necessary for major excavation projects while ensuring that discoveries benefit the entire African continent rather than just individual nations. The potential discoveries waiting beneath the sand could be worth these extraordinary efforts. If the satellite anomalies do represent major urban centers, they might contain the oldest libraries in human history, preserving written records from civilizations that predate all known literature. They might house astronomical instruments more sophisticated than anything previously discovered from the ancient world, or architectural innovations that could inform modern sustainable building techniques. Perhaps most significantly, these buried cities might preserve complete records of how ancient societies successfully adapted to major climate change. The communities that created these settlements lived through one of the most dramatic environmental transformations in human history, developing technologies and social systems that allowed them to maintain complex urban civilizations as their world changed around them. Their solutions to problems of water management, sustainable agriculture, and social organization in extreme environments could provide crucial insights for addressing modern global challenges. The next decade will likely determine whether the lost cities of the Sahara remain buried mysteries or become accessible sources of human knowledge. Technological capabilities are advancing rapidly, political conditions in the region may stabilize, and international recognition of the site's potential significance is growing. But time is also running out as natural erosion, climate change, and human activities continue to threaten sites that survived for thousands of years. The race to unlock the Sahara's secrets is not just an archaeological endeavor. It is a competition between human ingenuity and the relentless forces of time and nature that have already claimed so much of our species' early history. Whether the lost cities beneath the sand will finally tell their stories or remain forever silent may depend on decisions made in the very near future by researchers, governments, and institutions around the world. The desert keeps its own counsel, but for the first time, we may finally have the tools to make it speak. As twilight settles over the Sahara once again, painting the endless dunes in shades of copper and gold, we find ourselves where we began, standing at the edge of one of Earth's greatest mysteries. The wind that carries the scent of distant oases and the memory of vanished rivers whispers the same question that has haunted explorers and archaeologists for generations. What lies beneath the sand? We have journeyed through time and space, from the green paradise that flourished here 9,000 years ago to the cutting-edge technologies that may finally reveal its secrets. We have walked the paths of ancient astronomers who built stone circles to track the wheeling stars, followed the courses of buried rivers that once carried the commerce of continents, and traced the ghostly outlines of cities that may have been among humanity's first great urban experiments. The evidence we have gathered paints a picture far different from the empty wasteland that meets the casual observer SI. Satellite imagery reveals geometric patterns too regular to be natural. Ground-penetrating radar detects void spaces and density variations that suggest extensive architecture. Thermal sensors identify temperature anomalies that may mark the locations of buried stone foundations. Oral traditions preserve memories of cities and civilizations that once thrived or now only sand and doors. Yet for all our sophisticated technology and careful analysis, fundamental questions remain unanswered. Are the patterns visible from space really the remains of ancient cities? Or are they unusual geological formations that happen to create regular shapes? Do the subsurface anomalies detected by radar represent human construction, or simply variations in soil composition and mineral deposits? Can the flood myths and city legends preserved in oral tradition be trusted as historical memory, or are they merely symbolic stories about humanity's relationship with environmental change? These questions matter because they touch on something deeper than archaeological curiosity. The story of the Sahara is ultimately a story about human resilience, creativity, and adaptation in the face of overwhelming environmental challenge. If the buried cities exist, they represent one of our species' most remarkable achievements: the creation of complex urban civilizations in environments so harsh that we can barely imagine how people survived there, much less prospered. The communities that may have built these cities face challenges that dwarf those confronting any modern urban center. They created sustainable settlements in regions where water sources were unreliable, food production was marginal, and climate change was not a distant threat, but an immediate reality that reshaped their world within the span of human lifetimes. If they succeeded, if they built cities that lasted for centuries or millennia in the heart of the world's greatest desert, then their achievements deserve recognition as among the most impressive examples of human environmental adaptation in our species' history. But whether they succeeded or not, their story offers crucial lessons for our own time. We live in an era of unprecedented global environmental change, facing challenges to human civilization that many believe are insurmountable. The warming climate, rising sea levels, and changing precipitation patterns that characterize our modern world pale in comparison to the transformation that turned the green Sahara into lifeless desert. Yet life continued, cultures adapted, communities found ways to survive, and sometimes even to flourish in conditions that had never existed before in human experience. The techniques that ancient Saharan communities developed for managing scarce water resources, creating sustainable food systems, and building architecture adapted to extreme climate conditions could provide invaluable insights for creating resilient cities in an era of global environmental change. Their social innovations, the organizational systems that allowed them to coordinate large construction projects, maintain trade networks across vast distances, and preserve knowledge across generations of environmental uncertainty might offer models for governance and cooperation that could help modern societies address challenges that transcend national boundaries. Perhaps most importantly, the story of the Sahara reminds us that human civilization is both more fragile and more resilient than we usually acknowledge. Entire civilizations can disappear so completely that their very existence becomes mythical. Yet human knowledge, creativity, and social organization have survived environmental catastrophes that seem to spell the end of organized society. The astronomical knowledge developed at sites like Nabda Playa influenced Egyptian civilization for thousands of years. The artistic traditions preserved in Saharan rock art inspired cultural developments across Africa. The technological innovations created during the Green Sahara period provided foundations for urban civilizations that arose later in more favorable environments. As we stand at the threshold of potentially revolutionary archaeological discoveries, we face our own choices about how to respond to the challenges of our time. The technologies exist to unlock the secrets of the buried cities. The international cooperation necessary to investigate remote and politically sensitive sites is achievable. The funding required for major archaeological expeditions could be provided if governments and institutions recognize the potential significance of the discoveries. But time is not unlimited. Climate change, military conflicts, and natural erosion continue to threaten sites that survived for millennia. Each year of delay means the loss of potentially irreplaceable evidence about how our ancestors met challenges similar to those we face today. The decision of whether to commit the resources necessary to investigate the Sahara's buried secrets is not just an archaeological choice, it is a decision about whether we value learning from the past enough to invest in understanding how previous generations of humans created sustainable societies in challenging environments. The desert remembers, but it will not remember forever. The same forces that preserved ancient cities beneath the sand are slowly erasing them, grain by grain, year by year. Whether their stories will be told or remain forever silent depends on choices being made now in research institutions and government offices around the world. As the last light fades from the dunes and the first stars appear in the clear desert sky, the Sahara settles into the profound silence that has characterized it for thousands of years. But it is not empty silence. It is the quiet of a library waiting to be opened, a museum waiting to be explored, a treasury of human experience waiting to share its secrets with a world that desperately needs the wisdom of its ancestors. If you found yourself moved by this journey through time and sand, by the possibility that humanity's greatest urban achievements may lie buried beneath the world's greatest desert, consider supporting the researchers who are working to unlock these secrets. Subscribe to stay informed about new discoveries. Share these stories with others who care about understanding our past. And remember that the greatest adventures in human knowledge are not historical relics, but ongoing quests that need your engagement to succeed. The desert remembers. The question is whether we will listen.